For our last problem, a doctor prescribes 400 milligrams of a drug that decays by about 15% each hour. What is the half-life of the drug? How much of the drug will remain in the patient's system after 24 hours? So to do this problem, we'll use our exponential growth and decay formula, which is A is equal to A sub 0 e to the kt, where this is our initial rate, and then k is the rate of decay. So in this problem, we're starting with 400 milligrams. It's decaying by a rate of 15% an hour. And since it's decaying, we have a rate of negative 0.15 t, and t is measured in hours. If we're looking for the half-life of the drug, that means the final amount, if we start with 400 milligrams, will be 200 milligrams. All right, so we need to solve this equation for t. We'll start by dividing both sides by 400. And we now have the equation 0.5 is equal to e to the negative 0.15 t. So it really doesn't matter how much we started with. If we want the half-life, when you do that first step of dividing, it'll always end up to be 1/2, or 0.5 is equal to e to the growth rate times t. We'll take the natural log of each side. So we have the natural log of 0.5 is equal to, this allows us to bring down the power, negative 0.15 t times the natural log of e. We know that the natural log of e is equal to 1, so all that we have to do is divide both sides by negative 0.15. And if we do that, we'll find out the half-life of this drug. So the natural log of 0.5 divided by negative 0.15 gives us a value of about 4.6. And remember, this is being measured in hours. How much of the drug will remain in the patient's system after 24 hours? So our final amount is equal to our initial amount, which is 400. E to the k is negative 0.15, and t is 24. So to do this problem, all we have to do is enter this into our calculator. All right, so we have 400 times e to the negative 0.15 times 24. And that gives us a value of about 10.9. So 10.9, there we go. So in about 24 hours, about 10.9 milligrams would be left in the patient's system.